Hi everybody! So in today's video we're going to take a look at how we can evaluate limits algebraically, which means instead of looking at a graph, we're going to be dealing with equations of functions, and we're going to work with the equations. So one of the things we talked about today in class is that if you evaluate f of a, so in other words, if you plug in your number into your function, and f of a is a real number, which means there are no undefined values, and there are no piecewise functions where a is the breaking point, then the limit as x approaches a of f of x is just f of a, whatever you get when you plug that number in. So let's look at a couple examples where that happens. So the limit as x approaches 5 of x squared minus 4x plus 3. To check to see if this is going to work for me, where I can just plug it in, I'm going to take the number 5 and substitute it into this function, which means I'm going to have 5 squared minus 4 times 5 plus 3. Now 5 squared is 25, 4 times 5 is 20, plus 3. So 25 minus 20 is 5, plus 3 would give me 8. Since 8 is a defined value, there's no undefined numbers, it's not a piecewise function, it means that the answer to this limit function would just be 8. I'm sorry, the answer to the limit of this function, there we go, would be 8. For problem number 2, I'm going to take the number 1 and try substituting it into this function. So I'm going to have 1 to the 7th minus 2 times 1 to the 5th plus 1 to the 35th power. Now 1 to the 7th is just 1. 1 to the 5th is just 1, so this is going to be minus 2 and then plus 1 to the 35th power. 1 minus 2 is negative 1, plus 1 is 0, and 0 to the 35th power would just be 0. Since 0 is a defined answer, there's no undefined values and it's not a piecewise function, the answer here would just be 0. For problem number 3, again, I'm going to try substituting in the number 2 and see what happens. So I'm going to have 5 parentheses 2 to the 3rd plus 4 divided by 2 minus 3. Now 2 to the 3rd is 8, so I'm going to have 5 times 8, which is 40, plus 4 divided by, and 2 minus 3 is negative 1, which means I'm going to get negative 44. Since negative 44 is a defined number, it is not undefined, and it's not a piecewise function where that is the breaking point, my final answer here would just be negative 44. In general, the rule is that if you can plug in this number, you just plug in that number, and that's how you find the value of a limit using a function. Now, if you have a piecewise function, things can change a little bit. If you have a piecewise function and you're asked to find a one-sided limit, try substituting that x value into the appropriate side of the breaking point. If you're asked to find a two-sided limit, you need to check both sides. This is only important when the x value is the breaking point, because that means that the two different sides are being controlled by two different functions. So let's take a look at this example. Suppose you have this piecewise function. The first question is, find the limit as x approaches negative 2 from the left. Now I'm noticing right away that the negative 2 is the breaking point. So what that means is that the top function here is controlling all the values that are less than, or in other words, left of the negative 2, and the bottom function here is controlling all the y values that are greater than or equal to, or in other words, to the right of the negative 2. If I want to figure out what's happening when x approaches negative 2 from the left, I'm going to use the top function. Because the top function controls the values that are left of the negative 2. So what I'm going to do is take my negative 2 and plug it into the top function, which means I'm going to have negative and then negative 2 squared minus 8 times negative 2 minus 15. Now when I evaluate that, negative 2 times negative 2 is positive 4. So when I multiply by this other negative, I get negative 4 plus 16 minus 15, which means I get negative 3. So that would be my final answer for the limit as x approaches negative 2 from the left. Now if I want to find the limit as x approaches negative 2 from the right, I'm going to use the bottom function. And the reason I'm going to use the bottom function is because the bottom function here is controlling what happens to the right of the negative 2. So if I plug negative 2 into the bottom function, I'm going to have negative 2 times negative 2 minus 6, which would give me positive 4 minus 6, which is negative 2. And that would be my final answer. Now for problem number 3, it's just asking me to find the limit as I approach negative 2, which means I'm going to need to check both sides. Now luckily, I've already checked both sides in problems 1 and 2, and what I'm noticing is that those two answers do not match. So in other words, that limit does not exist. And finally, in problem 4, I have the limit as x approaches negative 3 of f of x. Now, negative 3 was not the breaking point of this function. Negative 3 is less than negative 2. And it is always less than negative 2. In other words, the top function here controls both sides because the top function controls what happens to all the numbers to the left of negative 2, and negative 3 is one of those numbers. So what I'm going to do is take my negative 3 and plug it into the top function, and I don't need to check the other side, because as long as the answer I get from this is a defined number that is not a breaking point of a piecewise function, then that's just going to be my answer. So I would have negative 9 plus 24 minus 15. Negative 9 plus 24 would be 15. Minus 15 would be 0. So the answer to this question would just be 0. Now let's take a look at what happens if we can't just plug in our numbers. So every problem on this page we've been able to solve by just taking our x value and plugging it into a function, because all of these functions have given us defined values that are not breaking points of piecewise functions. On the next page, we're going to look at what we do when we cannot just substitute. So when you try substituting and it doesn't work, in other words, the number you get is undefined, what do you do next? So if I take a look at this first limit, it says the limit as x approaches negative 2 of x squared minus 4 and x plus 2 is on the bottom. If I was to try plugging in negative 2 here, I would get a 0 in the denominator, which means substituting isn't going to work. So the first option that I would like for you guys to try is to try factoring. So here's what I mean. I'm noticing that the top of this function has an x squared minus 4, which is a quadratic that is factorable. So I would say that this limit is equal to the limit as x approaches negative 2. And I'm just going to factor the top now. So when I factor the numerator, I get x squared x plus 2 and x minus 2, not x squared. What am I doing? And in the denominator, I'm just going to keep the x plus 2 that was already there. Now what I see is that there is a factor of x plus 2 in the numerator and a factor of x plus 2 in the denominator. So I'm going to cancel those factors, and I'm going to write down my simplified limit. This would simplify to the limit as x approaches negative 2 of just x minus 2, because the x minus 2 was the only thing that was left here that didn't cancel. Now that I've factored and canceled something, I'm going to see if I can plug in my number and it'll maybe work this time. The first time I tried to plug in my number, it didn't work because of that x plus 2 in the denominator. This time when I try plugging in a negative 2, all I'm going to have is negative 2 minus 2, which is something that I can evaluate. So if I plug in my number now, so I'm going to take this negative 2 and I'm going to plug it into this x. I'm going to have negative 2 and then minus 2, which gives me negative 4. So the final answer for this question would be negative 4. Now, what if factoring isn't going to get you anywhere? For example, in problem number 2, I can't plug in the 1 because the square root of 1 is 1, and when I subtract 1, I get 0. So again, there would be a 0 in the denominator. When I can't plug in my number, and factoring is not an option because there are no x squareds here, there's nothing that I can factor, the next option would be multiplying by a conjugate. Now, you're going to try to multiply by a conjugate when you see the square root in the numerator or denominator. So I see a square root in the denominator of this fraction, which is kind of what's telling me I should probably try to multiply by the conjugate. Now here's how a conjugate works in case you need a refresher. The conjugate of the square root of x minus 1 is going to be the square root of x plus 1. And I need to multiply by that conjugate in both the numerator and denominator because that's the rules for multiplying when you have a fraction. You always have to multiply in the numerator and the denominator. Now here's what I'm going to get. My new limit is going to be the limit as x approaches 1. In the numerator, I'm still going to have the x minus 1 that was originally there. But then I'm also going to have the square root of x plus 1, which is what I multiplied by. In the denominator, I'm still going to have the square root of x minus 1, which was already there. But then I'm also going to have the square root of x plus 1, which was what I multiplied by. Now, when you're simplifying this, you are not going to multiply and FOIL out and multiply these binomials together in the numerator. You're only going to multiply the conjugates together, and here's why. My next step is going to be to multiply these two conjugates together by distributing. So in the numerator, I'm still going to have x minus 1 and the square root of x plus 1. But in the denominator, when I multiply this out, I'm going to have square root of x times square root of x, which is just x. Square root of x times 1, which is the square root of x. Negative 1 times the square root of x, which is negative square root of x. And then negative 1 times 1, which is negative 1. So then what I noticed is that the square root of x minus the square root of x cancels, which means my new simplified limit would be the limit as x approaches 1 of, in the numerator I'm still going to have parentheses x minus 1 and the square root of x plus 1. But in the denominator, my simplified denominator would be x minus 1. Now I can see that this x minus 1 and this x minus 1 are going to cancel. So my new limit that I'm going to try to evaluate will be the limit as x approaches 1 of just the square root of x plus 1. Now when I originally started this problem, I tried to plug in the number 1 and it didn't work because I got a 0 in the denominator. But now when I try to plug in the number 1, it's going to work because the square root of 1 is 1 plus 1 gives me 2. So my answer here would be the square root of 1 plus 1, which would be 2. So by multiplying by the conjugate, that part that caused me trouble, that denominator, got canceled, which is what I wanted to do. Lastly, and this is our last option, is to try to eliminate the denominator in your problem. So I'm noticing right now that there's nothing I can factor. There's nothing that it makes sense to multiply by a conjugate. And when I try plugging in the number 1, I'm going to get a 0 in this denominator that is within the denominator, and I'm going to get a 0 in this denominator, which is within the numerator. So when this happens, what we're going to do is just try to get rid of denominators, because denominators and fractions can sometimes make things a little bit more complicated than they need to be. So the first thing I would like to do is actually write in all of the denominators. Now I'm going to write this a little bit larger just so it's easier. I'm not actually doing anything right now. I'm just copying the problem so it's a little bit bigger. I can see this denominator clearly. Now for this minus 1, I'm going to actually write in a divided by 1 so I can see that denominator clearly. And then down here I've got 1 over x minus 1. I can see that denominator clearly. So in this problem there are 3 denominators, x minus 1, 1, and x minus 1. The common denominator here would be x minus 1. So what I'm going to do is multiply everything in the top by x minus 1 and everything in the bottom by x minus 1. Now when I do that, here's what happens. I'm going to distribute to the first term here in my fraction. So I'm going to have the limit as x approaches 1. The first term now is going to be x minus 1 over x minus 1, because x minus 1 times the 1 would just give you x minus 1. Minus, now I'm going to distribute to my second term, which is going to give me x minus 1 over 1, because that was the invisible denominator that I drew in. And then I'm going to distribute the x minus 1 to this fraction, which is going to give me x minus 1 in the numerator over x minus 1. I should not have made that line so long. I apologize. Now I'm going to try to simplify. The first thing I notice is that this x minus 1 cancels this x minus 1. So I'm going to have the limit as x approaches 1 of just 1, because that simplifies to 1. Minus, this doesn't simplify, but I don't really need the 1 there anymore. So I'm just going to write parentheses x minus 1 divided by, this simplifies because the x minus 1 and the x minus 1 cancel, and I get 1 again. Now if I simplify my new fraction, I'm going to have the limit as x approaches 1 of 1. Now when I distribute this negative, I'm going to have minus x plus 1. And I don't really need to write the over 1. Now if I try to plug in my 1, I'm going to have 1 minus 1 plus 1, which is just 1. And that would be my final answer. Okay, the last thing we're going to talk about today is how there are some rules for limits that we can use to simplify limit problems. So if you don't have algebra as an option, here are some options that you have. Here are some rules for limits. If we know that the limit as x approaches a of f of x is L1, so the first answer, and the limit as x approaches a of g of x is L2, so the second answer, then we can basically do arithmetic with those limits. So if we want to know the limit as x approaches a of f of x plus g of x, we would just take the answer from f of x and add it to the answer from g of x. If we want to know the limit as x approaches a of f of x minus g of x, we would just take the answer from f of x and subtract the answer from g of x. You basically can just do arithmetic with those answers. If we want to know the answer for the limit as x approaches a of f of x times g of x, we would just do the answer from number 1 times the answer from number 2. If we want to know the answer of f of x divided by g of x, we would just do the answer from number 1 divided by the answer from number 2, as long as the answer from number 2 is not 0, because you don't want to have a 0 in your denominator. If we want to know what happens when we take the root, it could be the square root, cube root, fourth root, fifth root. That's why there's an n there. It could be any root you want. You just do the root of the answer. And if you want to know what happens when you have a constant, so k just stands for a constant here, like some number like a 3 or a 4, times your f of x, you just do the constant times the answer from f of x. So basically, if you know the answers for the originals, you can do arithmetic with those answers to get new numbers. For example, given that the limit as x approaches 8 of f of x is equal to -9, the limit as x approaches 8 of g of x is equal to 2, and the limit as x approaches 8 of h of x is equal to 4, use limit properties to compute the following limits. Well, if I want to know the limit as x approaches 8 of 2 times f of x minus 12 times h of x, all I'm going to do is do 2 times the answer from f of x, which is -9, minus 12 times the answer from h of x, which is 4. 2 times -9 would be -18, minus 12 times 4 would be 48, so I would get -66. If I want to know the answer for the limit as x approaches 8 of 3 times h of x minus 6, I would just do 3 times the answer from h of x, which is 4, minus 6, which gives me 12 minus 6, which is 6. So basically, if you know some answers, you can find some other answers by just using arithmetic. All right, thank you guys so much for watching. I hope you have a wonderful afternoon, and I will see you next time for some practice.